Welcome, dear students. In our previous lecture, we discussed about the completing the square method to solve a quadratic equation. In this particular lecture, we will discuss about the discriminant method or formula method. Suppose we have a quadratic equation as ax square plus bx plus c equals to 0, where a is not equal to 0. So in this case, the discriminant of the equation, which is denoted by d, is equal to b square minus 4ac, where a is the coefficient of x square, b is the coefficient of x, and c is the constant term. So there are some points to be noticed. If d equals to 0, that is b square minus 4ac equals to 0, so in that case the quadratic equation has equal and real roots, means both the roots will be equal and they will be real. Fine. The second point is, if d is greater than 0, discriminant is greater than 0, that is b square minus 4ac is greater than 0. In this case, the quadratic equation will have distinct and real root. Distinct means unequal. The roots will be unequal, they will not be equal to each other, but they will be real. If the third point is, if d is less than 0, that is discriminant is less than 0, that is b square minus 4ac is less than 0, then quadratic equation has no real root. No real root. Please note it down. There is no real root. Okay, now if d is less than 0, that is b square minus 4ac is less than 0, then the quadratic equation has no real roots. So keep it in mind. In this case, in the third case, we do not find the roots because it is an imaginary root and this is not covered in our syllabus. So we will calculate roots in only cases 1 and 2, not in case 3. So now we have a formula, x equals to minus b plus minus under root b square minus 4ac upon 2a. If you remember, the same formula was derived in completing the square method also. So now we'll use this formula directly, or this formula can be also written in the form as x equals to minus b plus minus under root d divided by 2a, where a, b and c have their usual meanings. So now let us understand this method using an example. Suppose I have an example as 6x square minus x minus 2 equals to 0. So in this case, the coefficient of x square, which is a, is 6, b is minus 1 and c is minus 2. First of all, we'll calculate discriminant to check whether the roots are possible or not. So putting the values of b as 1 and a as 6 and c as minus 2, what we get? Minus 1 square minus 4 into 6 into minus 2, and the square of minus 1 is 1, and product of these three numbers is 48. So it amounts means now we get d as 49. Putting the values of d, b and a in the given equation, given formula, we get x equals to minus of minus 1 plus minus under root 49 divided by 2 into 6. So this becomes 1 and the square root of 49 is 7 and the denominator is 12. So now we have two values of x. One is x equals to 1 plus 7 divided by 12, and finally what we get? 8 upon 12, and since in the table of 4 the 8 comes at second place and 12 comes at third place, so we get x as 2 upon 3. Similarly, the another value of x is x equals to 1 minus 7 divided by 12. It comes out to be minus 6 upon 12, and finally x equals to minus 1 by 2. So we can say that the roots of the given equation are alpha equals to 2 by 3 and beta equals to minus 1 by 2. This is the formula method, or you can say it as discriminant method. So hope you understood it well, and we'll discuss another method of splitting the middle term method or fraction method in our next lecture. Thank you.